sizes. Size of each slice is random. Size of each slice is determined by the number of categories. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category. And pie charts are more visually appealing when the slices are different sizes.
D.
Yeah. C on that one?
Yes.
Yeah.
How are bar charts and Pareto charts related? Pareto charts are constructed from tossing a coin several times. They are identical. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest, going from left to right. I believe it's the last one.
Yeah.
It just orders them from, from like largest to smallest or something, doesn't it? Instead of having them be. Okay. Use the following information for the next 3 questions. We conclude that cat is normally distributed if it is greater than or equal to 10, and that equation. Is P the true proportion or the sample proportion?
True.
So it's asking for regular, right? So that's just.
Yeah, P is the population proportion, right?
Yes.
Mm-hmm.
Yes. Which would be the true, right?
Mm-hmm.
Not the sample.
Yeah.
Bye.
Okay. And we've got, what is N? N is still the sample size, right?
Yes.
Okay. If P equals 1/4, what is the smallest N that satisfies the requirement?
Would be
So we have. Let's see.
Wouldn't it be 40?
I think so.
Yeah, it's 40 times 0.25 is 10.
What about the other one?
So N equals 40. Do you have to check both of them each time, or can you just check one or the other?
Both.
Yeah.
Oh, gotta do both of them.
Yeah.
Well, whatever. So you know that the first one, the minimum that it has to be is 40. So I don't think the second one matters. It
well, it ends up being 13.3, so it's greater anyhow.
Yeah.
So we're going with 40.
So, well, let's see, 13 times 0.25 is 3.25. Yeah, I would think 40 would have to.
Oh, but let's see here. 4, 0.25.
Hey, are you saying?
So we're going with 40 on that one, right?
Oh, okay.
Well, I think it would be because the first equation, that's the smallest possible one that N could be.
Mm-hmm.
Or I think with the other one, if we use that, it's bigger, but I still think that that's probably the smallest that we could do. I think.
I think 40 is the smallest because
on the other one, I got 30 for the answer, but
So did I.
Yeah, but you have to go with the larger
Yeah.
one.
The
yeah,
large problem. Yeah. So I
right. I think it's 40.
Yeah.
I agree.
Okay. K, use the following information to answer the next two questions. N equals 24 and P equals 0.4. What is the meaning of P hat?
isn't it point
So
four
it's, yep,
What did you call that?
P hats.
P hat.
Okay,
It's like a P with a hat on it.
right.
They got real creative on that one. I like that one. I like that. X bar, X with a bar above it. It kind of makes it a little easier for me to like. No.
I think they should call it like carrot.
P carrot.
And-
P carrot. That's a good one.
So 24 and 0.4.
So now we're looking at the standard deviation.
Okay, so that is
Now we have to do
times 1 minus P
What's the square root?
divided by n square root, right?
Yeah, so it's going to be the square root of P times 1 minus P divided by N, and all the square root of that.
So P is 0.4. So do you get 0.1?
That's what I got, was 0.1.
In here.
Did you guys all get that?
Yes.
Okay. All right. Next question. Brittany's batting average is 0.300. We want to determine the probability she will get more than 35 hits in her next 100 at bats. N equals 100 and P equals 0.3. What is P hat? Okay.
Gonna be the same as P, right?
Yeah.
3.
It says round to 2 decimal points. So is it just 30?
I'm trying to trick you.
Yeah, because P and P hat will always
Be the same.
equal each other, right? So it's 0.3. What is the standard deviation of P hat? So we're going to do the same thing.
Like 0.46. Point 0.046.
That's what I got.
That's what I got.
Shoot.
Sorry, I'm almost there. What did you say you guys got?
0.046.
Perfect. Okay, what is the z-score?
You just plug that into the applet? Or no?
No, this one, there's a formula you work through.
So if p hat and p, let's see,
Are the same.
are the same.
How does that work?
So what's the formula?
So the formula is z equals p hat minus p divided by that same equation for the standard deviation.
So 0 divided by 0.04.
Minus P?
P hat minus p
Oh, P
divided by the standard deviation. But I'm confused because p hat and p are the same unless we go back to the question and there's something that's different.
Is the 35 have something to do with it?
Oh, so more than 35 hits. So
yeah.
if you took 35 divided by 100, you're going to get 0.35, 0.35.
Yeah, so it's going to be 0.35 minus, or 0.3 minus 0.35, right?
I think it's the other way around, isn't it? Isn't it
Yeah,
gonna
so
be
it's going to
minus
Yeah.
3?
0.3.
so it'll be 0.35 minus 0.3
Yes.
over the standard deviation, which we already found was 0.046.
So it's 0.05 divided.
So what did you guys get? I got 1.07.
Trying to get my calculator up.
I got 1.087.
Yeah.
1.087. Sorry, probably
1.087.
Mhm.
Yeah, that's what I got.
So now we're gonna. Oh, so it just wants the z-score. That's all it wants, right?
Yeah.
1 point. Well, because normally we'd go to the applet, right, and plug that in, and then find out what was greater than.
I think we do that on the next one.
Okay.
Yeah,
Probability.
the next pass for the probability.
Perfect. So 1.08.
Then we just shade to the right, right?
Correct.
So
Yeah,
I get 0.1385.
Yep.
we get 2.
So it'll be 0.139.
Jennifer,
Which one?
is that, did
Which
you,
one?
you kind of cut out and I didn't know if you said you got 2 or you got that 2.
If it was me, I got that also.
Okay. It was you.
So is the answer 0.139?
Yes.
Yeah.
Yep. Okay. We all ready to be on the next one?
Yeah.
14. Okay, if the true proportion of people who support a political candidate is p equals 0.52, n equals 2,000, we want to determine the probability that the results of this survey will suggest the candidate is losing the election, so getting less than 50% of the votes. What is the standard deviation of p? So,
I get 0.011.
That's what I get.
That's what I get. Yeah.
What did you guys, sorry, what did you guys say you got?
0.01.
0.011?
Huh?
Yep.
Because I think we have to go to 3, right? So 0.011. Okay, and then what z-score would you use?
So would you do the 50% for the number?
Yeah.
So we're going to get a negative, we're going to do 0.50 minus 0.52?
Yep.
Okay.
Divided by 0.011. So a negative 1.818.
Yes, negative 1.818.
So this part's hard for me. I don't understand where we need to shade on the.
So now I think you'll type in the z-score, negative 1.818, and we're going to be losing. So we're going to go only to the left of negative 1.818, I think.
That's what I think.
So
Okay.
0.035.
0.035.
0.035 is, I think, what I got.
Oh, that's the end.
Do we all agree on that, on as far as the shading and everything goes?
Yeah.
I do.
Okay. All right, I'll submit it.
I'm missing a question.
What are you missing?
Huh, I don't know. It says oh, maybe I just haven't saved everything. Let me do a save all. Sorry. You can go ahead and submit it. Yeah, okay, I just had missed saving it.
Okay, so we missed one. We got 17 out of 18, and it looks like question 10 is wrong. You know what we messed up there? Is p hat should be 0.35, not 0.3 for number 10.
Why?
I did
Well,
3.5.
think about the next question. We plugged in p hat was 0.35 when we did the z-score, the equation.
I think you're right. But you said you did 0.35 on number 10?
No, I
No,
did 0.3, but I'm 99% sure that it should be 0.35
Okay.
Well,
because we're looking at 35 hits out of 100.
Yeah, you're right. Because P hat is X over N. And that. Here, I'll put 0.35 and then I'll submit it and see what happens.
That should be right.
Yeah, that's right. 0.35 in there is right.
Okay. Would one of you guys mind, before you submit yours, is it okay if you leave it up for just a second? You can read me off
Oh, I can do that.
the answers. I'll pull up the second part here real quick. Okay. Okay, so question 3 was C, right?
Yes.
Okay. 4,
C.
C. Okay. 5,
True proportion.
okay.
6, the sample size. 7
Okay.
is 40.
Okay.
8 is 0.4, 0.4. 9 is 0.1.
Okay.
10 is 0.35.
Okay.
11 is 0.046.
Okay.
12 is 1.087.
Okay.
13 is 0.139.
Okay.
14 is 0.011.
Okay.
15 is minus 1.818.
Negative 1.818.
Yes.
Okay.
16 is 0.035.
Perfect. Thank you.
Mhm.
I had a question on the reading really quick, if you guys can help me.
Sure.
You know how we kind of work through problems in the textbook, and on this number 13, I just didn't understand the language of it, I guess. But it was the one that says for n equals 25 coin tosses, find the probability that P times 0.44 is less than P hat is less than 0.68. Explain that to me, because I just didn't understand how they got that.
You totally cut out on me there. So
Okay, so like in the text, do you guys print that out?
Yeah.
So it's number 13, right
Okay.
above elephant and donkey right there. I just didn't understand that question. I didn't understand that last part. Like if I see that again, I don't think I'll be able to figure it out. So can anybody explain that?
And this is, I'm sorry, you're talking about the online, like the textbook?
Yeah.
Yeah,
Okay.
under 3.3.1.
Right.
Okay, I can try to pull up this. For this lesson, 16.
Uh-huh.
Yeah.
Let me pull it up for you. Three point 3.1.
Mm-hmm.
Okay. Just toss. And what specifically is your question on this one?
Like I just don't understand that thing at the end that's like 0.44 is less than P hat is less than 0.68. I don't know what they're asking for, I guess. Like, how do you figure that out? I don't know where they got the 0.359 in the answer. I just don't know where all that comes from.
Like where it says for n equals 25, find the probability that p 0.44 is less than p hat is less than 0.68.
Yeah.
Interesting.
So is that the same kind of like what you were, is that kind of the same as finding the upper and the lower limits?
I have no idea.
Like confidence interval? Because that's kind of what it seems like it's doing. The probability of finding a number between 0.44 and a number between 0.68.
Mm-hmm.
But I
Nope.
don't know where they come from. Sorry.
Yeah, I don't either.
I'm not exact. Sorry, go ahead.
I was just saying, are you guys on 3.3?
1.
Mm-hmm. Do you guys
I
work?
think it's just kind of explaining. I mean, I think it's just kind of explaining the reasoning, behind it. Like, so it looks
So
like.
if you do, so the 0.7257 is if you put the z-score into the probability applet,
Yeah.
you get this 0.7257. So for 44% of the z-score is 60. And then if you, and then what is it asking if it's greater than, but I don't know where the 0.0359 is.
See, when you put that z-score in the applet,
Uh-huh.
when you shade everything just to the right, you get the 0.0359. But I don't.
So, oh, okay. So
But I don't.
0.6. So when I put the 0.6 into the applet and shade to the right, I get a 0.2743.
Yeah. So apparently nobody knows what it means either. So I hope I don't ever see one of those because I won't be able to
Oh, there's
figure it out.
Into the applet? What were you putting into the applet?
The 0.6, the z-score, to get the 0.7257. And so
7.2.
So you're saying you were putting in the negative 0.60 z-score? Or were you putting in the 1.800 z-score?
I put in the 0.60 z-score, or negative 0.06. Either way, it's the same.
Okay.
And shading the center and the left, and that gives you the 0.7257.
But if you shade the center and to the right, you still get 7.257 also.
Right.
So still right. Okay.
So either way, if it's going to be less than, it's going to be, I mean, just depending on your z-score. But I think it should be shaded to the left because you're using the negative.
Right. And see, with it being negative 0.6 and you want it less than, I would have just shaded to the left, and that's wrong because you have to shade the center.
Yeah. But I don't, and so is that, 0.7257 divided by 2 equals 0.3. No.
Question 12, the one that gives an answer of 0.257 wants to know the probability of the proportion of that the proportion of success will be greater than the 0.44. So that would be, like you said, the middle, right.
Middle and to the right.
Right.
But
so
I
that
don't know where the 0.0359 is coming from. Unless you have to find the z-score for the 0.68.
Yeah.
So you're wondering where the 0.0359 comes from?
Is that the z-score of the 0.68?
Say that again?
Is that the z-score of the 0.68?
No. That's the 0.0359 is what you get with a z-score of 1.8.
Probability
Yeah.
in the area box.
Mm-hmm. So that's why.
Oh, okay.
But see, in that question, that just doesn't make sense to me. Just because everything it's 0.44 is less than p hat, and the p hat is less than 0.68.
Well, so the p hat is greater than 0.44, but less than 0.68.
Right. So they're just telling you to subtract those two. 0.7257 minus 0.0359. And then you get the
Looks
answer.
like it.
Yeah.
I think so.
But yeah. Okay, I hope I never see that question again.
Here, here.
So, should we move on to our project?
Yeah. Had any great ideas?
Well, let me pull it up real fast. So, if I'm understanding correctly, we each kind of sign up for, that we kind of are the main writer for each different part of the project. And then that one person, if I'm understanding correctly, is the only one that turns it in for our group for that week. But all of our names are like on it. It looks like at the top. But obviously we don't work, we can all either work on it or do parts of it or something like that.
Right.
Or however you guys want to do that. But I do know that the first thing we kind of have to come up with is a question that we have. They gave some examples of, are there 1,000 chips in every bag of Chips Ahoy? Brand A paper towel stronger than brand B? Is there a difference in the prices of books at BYU? Anyways, there's just a list of questions. Do you guys have any kind of questions that you thought about?
Yeah, I couldn't think. I don't know.
The one I was thinking of, unfortunately, it doesn't have anything to do with food, is that I don't know how to word this right, but I wanted to see if a 2 credit class at BYU has a different amount of homework as a 3-hour or 3-credit class. To try and prove that, because this is the problem, and I don't know if this is the same as at every school, but I've had 3-credit classes that probably could have been a 4-credit class. There is so much homework. And the same with a 2-credit class. It should be a 3-credit class. So it would be something where we'd have to survey students at BYU Idaho to see how much homework people are doing in a 2-credit class and a 3-credit class, to see if what the school is saying, 3 hours per each credit is what you can estimate, to see if that's right or not.
It's an interesting question.
I also thought,
don't buy the whole homework thing either. So
yeah.
I think I do way more than what they say. And that might just be because I'm really slow, but I don't know.
Well, and I think when they say that, you bring up an interesting point, Jennifer, because I think when they say that, though, they're telling you this is the minimum that we expect from you, kind of a thing.
Pass the class.
So I think they're saying, here's the minimum to be successful, to pass the class, but it could be onwards and upwards to whatever, you know what I mean? Right. So it would be nice if they would take that into consideration a little bit more as far as the time that we do spend. I know I spend a lot more time in most of my classes than probably is, the minimum or whatever, but yeah, that's something interesting.
I just see that question a lot when people are getting ready to register for classes, Is this really a 3-credit class? Or whatever.
I think like 264, 265, Patho, those should be at least a 4 or 5-credit class. I like that question.
Yeah, I think that's a good question. My question is kind of silly, actually. The only reason I thought of this question is because it always comes into discussion with my siblings and my brother-in-laws and my sister-in-laws and stuff. For some reason, it's just this silly thing. And I have a brother-in-law that's really OCD and anyway, so last time we all got together, I don't know, he randomly brought this up, and I thought it was interesting because I've never thought about it before. And but he was saying when he puts the toilet paper roll on the dispenser, that it drives him crazy when it goes underneath instead of over the top or something like that.
Yeah.
That drives me nuts.
Everyone else chimed in and was like, "Oh my gosh, I totally agree," or "I think it should be this way," and it turned into a 30-minute discussion, and I was kind of surprised because I don't care. I don't know if I've ever really done it a certain way or not, but it kind of made me think about it. So anyways, my question was, do people prefer the toilet paper roll to go over the top or underneath? Because I don't know. I just thought it was kind of a silly question, but people really are passionate about it, I think.
I think they are passionate about it. I know I am.
I'm curious. What's your preference?
Over the top.
Oh, okay. I do it over the top, but it doesn't drive me crazy enough that I have to switch it or anything.
Over the top, and I will switch it.
And I
have heard some parents of young children say that they do it the other way because then they don't end up with all the toilet paper on the floor. It rips off easier. Right. Yeah.
Interesting.
But
that's a good one.
I like that question.
I think we should do that one.
Yeah.
Well, and I think it would be easy to get the data for it, and I think it would be there's not tons of answers. It's either there's 2 answers. You know what I mean? So we don't have. I think it would be simple in that sense.
3 answers.
I think 4 answers.
4?
4?
No, maybe 3. Yeah. So over the top or under, and then change it or not change it.
Or I don't care.
Yeah.
Or it
Yeah.
doesn't matter to me, or I've never noticed, kind of a thing. Yeah.
Okay. I like that.
Yeah.
Yeah. So, anyways, that's
It
kind
could
of
even it could even be like, if it bothers you, how bad, and then a 0 is I just leave it, ignore it. 5 is I have to change it.
yeah.
That kind of thing. I don't know. However,
That's a
I
good
mean,
idea.
So,
So do we want to split up the design or the steps, I guess?
so I'm wondering if we can take two different approaches here. We can all sign up for a different one and just have that person kind of do 100% of the work, and then kind of maybe email it to everybody and say, this is what I have. I didn't know what to put for these ones. What do you guys think? And then we can all kind of throw our comments on there, and then they can submit it. Or we could put it on a Google Doc, and everybody just kind of pipes in what they want, where they want it, and how they want
Google
it.
Doc because it's instant changes, and especially because you can do, like a PowerPoint on Google Docs as well.
Okay.
So let's do that.
So we can.
Maybe we still need to sign up because that's part of the assignment is to sign up.
Yeah.
We can all work on it together.
And then we'll just say whoever was the main writer for that, just kind of make sure that that person's kind of in charge for that week and make sure things get done, and then be the one to submit it at the end of the week or whenever the due date is, probably.
Okay.
If that works for you guys.
mm-hmm.
So does anybody have preferences? Do you want to design the study, Erica, since you were kind of the one that came up with that idea?
So I'd be happy to be the one. This week is kind of crazy for me. My sister-in-law is getting married. We have a lot of family coming in town. I'd be happy to take charge on that if needs be. I know another week might be better as far as if it was like a heavy workload or something. Do we need to have the study designed this week? I think by Saturday. I think.
I don't think it's too difficult though, isn't it? Just like explaining what we're doing.
So there's just a bunch of questions we have to answer. What's the population? State your research question. There's probably there's like 20 questions, I think, total. And then we just have to decide. Some of these, I wouldn't know like exactly what to put on there. Like, what is your response variable? I don't know.
I think these are things we need to talk about right now.
Yeah.
So we're going to have all of these answered for you.
Okay, so I have it pulled up in a Word doc. I can just start typing if we want to just go through it.
Okay.
Real quick, if you guys have time. If not, then
I'm kind of pressed for time right now. Do you think we could meet even later today? I could meet again, but I've got to I have to go feed these missionaries at a zone conference an hour away.
Okay. So later today, basketball has started. I help coach basketball.
Uh-huh.
And so I'll be gone from like about 3:30 p.m. Mountain time until like really late tonight. We have to travel for like a jamboree type thing. So if it was
even tomorrow sometime, I don't know. I'm sorry.
What about tomorrow? Would be better for me too.
What is tomorrow? Wednesday?
Wednesday?
I could meet. Yeah, I could meet tomorrow as long as it was after. I have class until 10:30, 10:45. So I could meet from 11 o'clock.
That would work
Anywhere
for
from-
me.
That works good for me.
Okay,
At 11.
yeah.
I have a
So
dentist
that's
appointment at 10.
Mountain time.
So that would be when you have your dentist appointment,
Is at 10.
which is 11
Pacific.
time.
Yeah.
Okay.
So that won't work for you then, Jen?
No.
Mhm.
Okay.
But after that, I can do anything after that.
Are you okay after that, Erica?
Yeah, as long as it's before. Yeah, I could do it if it was. Let's see. So your appointment's at 10. What do you think? Like an hour, hour and a half?
Yeah, so like if we said noon or something, I could be back home in time.
So is that 1 o'clock Mountain time then?
Yeah. Mm-hmm.
Yeah, I think I could do that. I could do 1 o'clock.
Okay.
All right. Sounds good.
Okay. I will 12 o'clock.
Okay,
All right, thank you.
sounds good.
All right. We'll see ya.
We'll see you. Bye.
Bye.